ways are there to solve math?
Many!
Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
Measure first. I need you to double check yourself. So the second equation for solving perimeter is?
2 times length plus 2 times width.
Good afternoon and welcome to the elementary edition of Count on Us. I'm Sherry Sternberg.
I'm Mr. G.
Mr. G, he's been playing the air piano, the air guitar, he's been jamming to the music, and now we're going to jam to some mathematics.
Yes.
We have a lot going on today. We have our good old Challenge 24. We love
Challenge
it.
24 is in the house.
Actually, before we do that, let's tell them how to get in touch with us.
You need to call us at 301-772-0080.
That's the number. And you can also reach us via the computer. If you're watching us streaming in, you can reach us at
COU,
for Count on Us,
at pgcps.org. Prince George's County Public Schools .organization.
And some of you have watched the show. You've seen some students from Prince George's County do our email corner where they have answered questions that students just like you have sent in. So how can you send those in? Let us remind you about that as well.
You send that in
To COU
at pgcps.org.
All right,
Ta-da!
so that's different than the web. To reach us on the web, you're going to www.pgcps.org and clicking on Count on Us on the screen.
I think I said COU.
Yeah, I did. Now it was connected to me. I got it. So you reach us a lot of different ways, and we're hoping that you're dialing in and trying to reach us by phone right now, because we're here live, ready to answer your math homework questions. And
no one
tell
has
us,
homework tonight.
No one has homework tonight.
It's warm.
It's warm out.
It's
You know,
warm.
there's a lot of mathematics in temperature, in weather, in climate. And I hope that you know the temperature was up today. It was warm. Well, yesterday
No, it was cold. It
no,
was
that's
cold
right.
yesterday.
Yesterday was cold. There was some stuff on my car on Sunday. Stuff going on. So look at the temperatures and do some math with those numbers that are going on. And let's do some math with the Challenge 24 right now.
Okay.
Our numbers that we want you to copy down, knowing you need to use all 4 numbers one time each. Any of the computations, any combinations of addition, subtraction, multiplication, and division to get to our challenge number, which is 24. So, card A, jot down these numbers.
1, 5, 2, 9. Card B is 3, 4, 7, 2. Card C is 4, 2, 4, 6. And card D is 7, 2, 5, 3.
Think about some strategies as you're working with these numbers, what kind of patterns you see in the numbers, what kind of...
I solved A.
You solved it already,
solved it.
immediately, just
I
like that.
solved
Now,
it.
it is a 1 dot, so that is
One
the
dot.
easiest one to
Yeah.
solve. These are supposedly, because sometimes I solve those 2 and 3 dot ones faster than the 1 dots. 2 dots are a little more difficult. 3 dots are supposed to be the most challenging. Note, most of the cards have at least, which means it could have more than 2 solutions. So make sure you listen to all of our callers so that you're not calling in with the same solution as someone else. Once you get a solution, don't stop. Try for another solution or try another card.
Yep.
So you are ready.
I solved B.
Now you solved B.
Oh, my goodness.
See, I'm
on a
talking while you're
roll.
solving. Now you start talking and I'm going to start solving. Let's see what we got because we have a caller on the line.
Do we have a visitor from the TV world? Yes. Is that
Hello.
Tamawa?
Yes.
Welcome back. How are you?
Good.
Did you have a good break?
Yes.
Very good, very good, very good.
What school's Tamawa? I know
What school you
regular.
going?
Park.
Dodge Park.
Dodge Park.
That's my school.
You knew
Tamawa,
that.
have
You
I
knew that.
met you?
Yes.
You have? I have? Okay.
All right, well, let's meet this math problem that we have to help you solve. What is it?
A division problem.
Division. Go for it, Mr. G.
Okay, what are the numbers?
62 divided by 6.
62 divided by 6. All right, do you know the first question that we're going to ask?
Yes.
What are we going to ask?
You have to divide.
Okay. So we're going to look at this 6 in the tens place, and we'll say, how many 6s can we share with this 610?
1.
Good. If we put these into groups of 6, each group will get 1 of the 10s. And how many will I have shared out?
6.
And how many will be left over?
0.
So I've shared out all of my 10s, and then I have
To
2.
bring the 2 down.
Okay. All right. Now, what grade are you in, Tamawa?
4th.
4th grade. So you're
Yes.
you have remainders, correct?
Yes.
Okay. So we have a remainder of 2. Well, wait a minute. How many 2s can we share with 6?
0.
0. That's what actually has to happen there. So we can't share them. That means we have a remainder left of
2.
2. Now, if I didn't put that 0 there and I didn't go through that, that would be 1. And then do you know how we check this?
No.
Well, we can say now 6 times 10. What's 6 times 0?
6 times 0 is 0.
There you go. And what's 6 times 10?
6 times 10 is 6.
60. So now I have 60, but see that remainder 2?
Yes.
You know what I have to do with that remainder 2?
Yes.
What do I have to do?
Add it.
There we go. Now, this looks exactly like this. Ta-da! You see how that works?
Yes.
Okay.
All right, Tamawa, I wrote your name down. I'm folding it in half, and I'm folding it in half again. Do you know how many pieces that makes?
4.
4, good. Half makes 2, and another half makes 4. So I'm folding it into fourths. I'm taking this paper with your name on it, fold it into fourths, putting it in our cracked red apple.
Hungry apple.
Hungry apple that has a crack in it. So we better get that glued or get a new apple. But your name is in there, Tamawa, so keep watching till the end of the show. Call us back
Can I
if you
do
have...
a challenge?
You solved one already?
Yes.
All right, and
Ready
I'll
for a
accept
challenge.
that
I love it. I
because
love
Mr. G
it.
solved one that quickly, so
love
let's
it.
see. Which one would you like to solve?
D.
D.
Whoa, that's the big kahuna right there.
7, 2, 3, and 5. 7, 2, 3, and 5. And you're going to take us to 24 with those numbers, right?
Yes.
Let's hear it.
7 times 3 equals 21.
It does.
21 plus 5 equals 6.
Equals what?
6.
Not just 6.
I mean 26.
26. Bell.
26 take away 2 equals 24.
That is correct. And that's why in the beginning we said 3 dots, 2 dots, 1 dot. However you look at them, some are easier than others, some are not. So don't let the dots phase you. Don't try to solve the problem. Depending on the dots.
Wow.
All right. So excellent. Your name is going to go in our apple, our hungry apple, Tamawa, for the second time for your challenge. Excellent job. Other people, please continue to solve challenge with the 3 dots, but just give us something different than Tamawa did.
That was
So
great.
in half again, making fourths. And excellent job. Thank you, Tamawa. We have another caller on the line, so we're going to go right to that caller and help that person who I think is Topanga. Topanga, I can hear myself talking. That means your television volume is on and it needs to be turned all the way down.
Much too loud.
Talk to me through, write that on there, please. Talk to me through your telephone and watch me on the television, okay?
Yes.
All right, Topanga, what school do you go to?
Carmody Hills.
Carmody Hills, and what grade are you in?
4th.
4th grade, and what problem are you working on that we can help you with?
Ooh, you still have to turn your TV down.
9 times 20, 92.
Okay. And we're hearing that echo still, so that means the volume's still on your television. Okay, I need you to turn that volume down.
Turn the TV down.
Okay.
All the way down.
All right, did you turn it down?
Yes.
All right. So tell me the problem again. It's a division problem or a multiplication problem?
Division.
Division. And what is it?
Hello?
Yes, what are the numbers, Topanga?
9 divided by 92.
9. Okay, Topanga, we are still hearing you. So your volume can't be turned down because we're hearing you 2 times. We're hearing you once on the phone and once on the television. So we need that television turned down.
Okay.
Can you hear me through the telephone?
Yes.
Okay, that's all you need to do. Is this what your problem looks like? You said 9 divided by 92.
Yes.
Look, are you looking at it?
Yes.
And this is what it looks like?
Huh?
And look at my picture on the screen. Is this what it looks like?
It says 9 divided by 92.
92, but look how I wrote it. I wrote it the way you said it. 9 divided by 92.
9 plus. Okay.
Is 9 on the inside of this little division symbol or on the outside? Because in 4th grade, you don't typically do problems like this. This problem can be solved, but you have to use decimals, and 4th graders aren't using decimals yet. So which one, does your problem look like that, or does your problem look like 92 divided by 9? Which one does your problem look like, the first one or the second one?
The second one.
Yeah, the second one. So be careful the way you read your problem. It's not 9 divided by 92, it's 92 divided by 9. We want to know how many groups of 9 are in 92, and this is a very similar problem to the one that Mr. G just did with the other student that called, Tamawa. So it's a very similar problem, and we have 2 of the same numbers just like he did. He had 6 and 62. You have 9 and 92. So if we look at this, we want to think how many 9s or groups of 9 are there in 90?
92? 18.
Well, let's just look at the 9. How many 9s would there be in 9?
It will be
What number times 9 gives you 9?
1
Just
times
1.
9.
Exactly, 1. So that's the same with 90. Because we're looking at the tens place, so we only have 1 10. So there would be only 1 9 in 90. Okay, 10 of them, but we're in the tens place. So 1 times 9, you just told me, was 9. When we subtract, 9 minus 9 is?
9 minus 9 equals 0.
Is 0. We bring down that 2. 2 is less than 9, so we can do the next
Bring
part.
down your 2.
Right, and how many 9s are in 2?
9
None.
can go into 2.
So you have to remember to do what?
Regroup.
Well, what do you have to put up top?
Okay, now 9 can go into 2.
Are there any 9s in 2? Can you count 9 out of 2?
No.
No, so you're going to put a 0 up there. Okay? 0 times 9 is?
10.
0 times 9. What's anything times 0?
0 times
0.
9 equals 9.
No.
Equals 0?
Equals 0. If I give you 9, no times, 0 times, you have 0. You have nothing. I can give you nothing 1,000 times. You still have nothing, right? All right. 2 minus 0 is 2. So just like the last caller, this 2 becomes your remainder. Okay?
So it's 10 remainder 2.
Right, and let's double check that. How much is 10 times 9?
10 times 9 equals 90.
Exactly. 90 is not what you started with, though. You started with 92. So take your remainder, add it back in. How much is 90 plus 2?
90 plus 2 is 92.
Is 92. That's what you started with. That's what you ended with. That tells you that this quotient's the answer in a problem of division. That tells you your quotient is correct. Okay?
Yes.
Good job. Topanga, I think your name's written, or maybe not.
Yep.
Sleeping on the
Dereliction
job.
of duty.
So do I get a treat?
Well, if your name is the one that gets picked out of the apple, just getting into the apple is a treat, but getting picked out gets you a prize at the end of the show. So keep watching and see if you're one of the winners. If you call back and do one of our challenges, I'll put the number back up for you. If you call back and solve one of these challenges, you get your name in another time, which increases your probability of winning a prize at the end of the show.
Probability.
All right, so do you have these numbers copied down?
Yes.
All right, 1, 5, 2, and 9, 2, 3, 4, 7, 4, 2, 4, 6, 2, 3, 5, 7. Excellent job. Thank you, Topanga.
Next caller. Anyone out there in TV land?
No.
We're here. We are here. We are here. We are here. Like Courtney Here's a Who. We are here. 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 We are here.
All right,
Alrighty.
so let's see what we got going on. I know that I was talking to some 5th grade students who were asking me about equivalent fractions. Yes, 5th graders don't like equivalent fractions.
I don't know
but
why.
I know, and if you know your math facts, and that's the key behind equivalent fractions. You have to know, that's the key behind fractions in general. You have to know your multiplication facts. So Topanga and Tamawa, our 4th graders that called in, guys, learn your math facts. All our 4th graders out there, learn your math facts. So let's look at a fraction and how we might make an equivalent fraction. Go ahead, Mr. G.
Okay. I'm taking my wonderful, lovely little rectangle here, and it is one whole amount. Well, a fraction is a part of a whole. So I could take my fraction, take my rectangle, and cut it into 2 equal parts.
Well, relatively speaking, let's make that a little closer. We're drawing freehand, and we're not measuring, and we don't have graph paper, so we're trying to get as close as we can.
Ooh-wee, that looks a little bit better.
A little bit better.
Okay, so so let's say that I color in one side. Whee!
So you had a hole, and you divided it into 2. So now you have
I
2 pieces.
1 piece, 2 piece. So as a fraction, that is 1 out of 2 pieces.
Okay.
Now, an equivalent fraction, we don't change the size of the whole amount. What we're doing is changing the size of the pieces by cutting it up into more pieces.
And by pieces, we're always referring, denominator represents the total pieces. So remember, we started with 2 pieces. There's our denominator. All right?
Bam.
Keep going.
So if I take this same rectangle that's already been cut into 2 equal parts, and I cut it again, now I have
now you have 4 parts.
1, 2, 3, 4. Those same 2 parts now have
Shaded.
4. Now the same shaded parts, the 1 got cut into 2. Now I didn't expand the shape, I didn't make it bigger or anything. I just cut it up into more pieces, and I also cut them into smaller pieces.
And you know what's confusing? You said you cut them into smaller pieces, but your numbers are getting bigger.
Because I made more pieces.
Yeah,
I made
that's
more
what's
cuts.
confusing.
Right. So when you see that 4, you think, well, 4 is bigger than 2.
Nope.
But actually, with fractions, that denominator can make everything smaller. The actual size of the piece has become smaller. So I can share this with more people, but
Getting
each
a littler
person
piece.
will get a smaller piece. So since I cut the 2 into 4 pieces, the shaded amount, which was 1, now has 2 pieces that are shaded in.
So you just did a little math. You did it here with a visual drawing, but then you did some little numbers here, which I'm not sure the kids can see, but you said times 2. So
That's what I did.
for
Because
equivalent
each
fractions,
piece got cut into 2 parts.
okay, so each piece got cut into 2 parts. So we went from 2, and we divided each of those into 2 more pieces, and we made it 4 pieces.
There we go.
Whatever we do to our numerator, we must do to our denominator. I'm sorry, whatever we do to our denominator, we do to our numerator. So we have to multiply that by the 2 as well. So now we have 2/4. Visually, we have 2/4 numerically. We can see it both ways. All right, so we can still divide more, can't we?
We can. We can just keep on going and keep on going
Now,
and keep on going.
one thing about dividing, though, is, let's say if I want to divide it again, is this acceptable for me to just divide it here and be done?
Absolutely not.
Not.
Because
Not.
we did it to one side, we also have to do it to the other.
So
That's
the thing
not-
about fractions and our denominator, the pieces always have to be equal. equal, fair pieces. So right now, these two are smaller than these, not fair. They're not equal pieces, and our denominator always represents the total number of equal pieces. All right, so that means I have to take this one and divide it here.
There you go.
So now my total pieces went from 4, I kind of doubled them, because I took each of the 4 and divided them in half, making 2 more, so now I have 8.
Ta-da!
All right.
1, 2, 3, 4, 5, 6, 7, 8. I made 2 more cuts from the 4, and now we have 8 here. So, out of those 8, 1, 2, 3, 4
are colored in.
Are shaded in.
And that same concept of timesing by 2, 4 times 2 gets me to the 8. 2 times 2 gets me to the 4. But even better than that, if I go back to your original 1/2, I can go from 2 to 8, I'm timesing by 4.
1, 2, 3, 4.
And 1 times that same 4 is going to give me my 4 pieces.
1, 2, 3, 4.
So again, the pattern with the equivalent fractions, we don't always have to multiply 2. We're keeping them equivalent as long as we multiply the numerator and denominator by the same number, which means we're cutting them into the same number of pieces. We're keeping it equal. We're keeping those pieces equal. We got a lot more with fractions coming, but we have some callers on the line. So why don't we break from fractions and let's go to the callers, because I know Topanga was diligent and she persevered, which is a very important math skill to solve that challenge. So let's see what you came up with. Oh, let's see who's on the line.
Hi.
Are you back?
Yes.
Okay, you ready for a challenge?
Yes.
Which card did you pick?
24 challenge.
Which card?
B.
Card B? 3, 4, 7, 2?
Yes.
Very good, very good. Let's see what we can do here. 3, 4, 7, 2. All right. Tell us your strategy here to compute to 24.
7 times 4 equals 28.
Very good. Okay.
28 minus 2 equals 26.
Okay.
26 minus 2 equals 24.
You already used the 2.
You have a 3 left. Sounds like a back to the drawing board, which is fine. Revise your thinking, come up with the new numbers, make it work, and give us a call back, okay?
I have one more.
All right, go ahead. We can try that.
What do you have? Same card?
No.
You have a homework problem as well?
Yes, a multiplication.
Yeah, let's do that, because homework's more important than Challenge 24s, even though they're fun.
What's the problem?
59 times 5.
59 times 5?
Uh-huh.
That's it? 2 digits times 1 digit?
All right, sounds good.
Okay, so first one is 5 times 9 is what?
5 times 9 equals 45.
Okay.
Good job.
You know what we're supposed to do?
Yes.
Put down the 5, and what do we do with the 4?
Put it on top.
On top of where?
On the 5.
There we go. Because that belongs in the tens place. Now we're doing 5 times 5. That's really 50, but 5 times 5 is?
25.
Plus 4 more?
29.
There you go. That's really 290, and the total number is 295.
All right, and again, the key is knowing those facts. So you had a division
Have
problem,
to know
you had a
them.
multiplication problem. Both of them, the key is knowing your multiplication facts.
You have to know them. Good job, Tamawa.
All right, Tamawa, your name is going in again. Right now, you have the most likely, the probability is most likely with your name since you're in there 3 times. But we have other callers who have an opportunity now, so let's see who we have on the line. Hi, this is Count on Us. Who do we have on the line?
Are you there? Are you there? Are you there?
You really like Courtney Here's Who, huh?
We are here. We are here. We are here.
But they're not saying that. What are you saying out there? Can we? Oh, they're not there. They're gone.
I see math students. No?
All right. Well, we're gonna go back to fractions because we really like fractions, and we feel like we have a lot to say about fractions. So we're going to tell you some more. We've been talking about equivalent fractions. We've been talking about how you can have a visual representation. You can take a picture and divide it and divide it and divide it and keep showing equal pieces. Denominator is the total number of pieces. Numerator are the parts you're talking about, the parts you gave away, or the parts that are left, or the parts that are shaded, or the parts that are not shaded.
Right.
But
be careful of the question being asked.
Perfect. So read the question carefully. Also want to make sure you know that you can take any number, as long as it's the same number in your numerator and denominator, and get an equivalent fraction by multiplying both numerator and denominator by that same number. Because that means you're not changing the value, you're just changing the amount of pieces or the size of the pieces. But the amount that you started with is still the same. The pieces are just smaller.
Right. That one whole is still one whole.
It's still one whole. And the other thing I want to make sure you understand is that the same way we multiplied and got bigger numbers, even though we got smaller pieces, we can do the reverse of that. So I can start out with a fraction like 12/18.
Ooh-wee.
And I can make an equivalent fraction with 12/18.
Yes, you can.
I can go up and multiply with 2's and get bigger, but I can also divide and get a smaller number than 12/18 as well. So let us do that really quick. Let's see, 12, actually I could use a greatest common factor, or I could just use any factor. They'll both give me equivalent fractions. So let's divide both by 2. I'm working backwards. You're not typically used to that, but I'm saying 12 divided by 2, that's going to give me a 6. 18 divided by 2 is going to give me a 9. So 6/9 is equivalent to 12/18.
Ta-da.
If we go bigger, 24 multiplying by 2. 18 multiplied by 2 is 36. I almost wrote 46. 36, and this is an equivalent fraction. So we can go either way, multiplying or dividing, long as we're using a same numerator and denominator to get there to get equivalent fractions. One of the things we'll talk about after we come back take our next caller and come back from the break is the fact that I didn't use the largest factor, therefore I don't have right here the least
common multiple.
Least common multiple. I don't have the smallest fraction. It's not in simplest form because we could simplify it. Simplifying is also finding equivalent fractions. But let's see what Felicia wants. Got a lot of multiplication going on. That's this time of year. Third graders are working on that as well.
Felicia, how are you?
Yes.
How are you?
Good.
I'm hearing both of you.
Turn your TV down. Turn your TV down. Turn it, turn it, turn it, turn it down, down, down. And talk into your phone.
So volume's off, all the way down.
Don't turn the TV off, though.
Hello?
If you hear the click, we're off. Don't have to turn your voice volume down, just the TV volume.
Okay.
All right.
Felicia, what school are you calling from?
Cherokee Lane Elementary School.
Say it again.
Cherokee Lane.
Oh, Cherokee Lane. Cherokee Lane. Hi out there in Cherokee Lane. So what is your question?
What is 48 divided by 8? I mean by 6.
48 shared by 6.
I like that one because it's basic facts.
Nice.
I love the basic facts. They're quick, they're easy, they're down, they're dirty.
Okay, Felicia, if I have 4 10s, can I share them with 6 friends?
What did you say?
If I have 4 10s, can I share those 4 10s with 6 friends?
Yes.
I can? If I have 4 pieces of candy, I can share them with 6 people?
Wait, no.
No. Even though they're 10s, they're like
whole pieces together.
They're like a Twix bar. So if I have 4 Twix bars, I can't share them with 6 friends because someone won't get any, right?
Mm-hmm.
You follow me? So I can't share those. Wah, wah. So what I actually have to do is I have to break them up now into smaller pieces. That's what actually is happening here. So I could break them up into 48 equal pieces the same size. Now I can share 48 pieces with 6 people. And do you know your math facts? Do you know your 6 times tables?
Uh-huh.
You know 6 times what number will give you 48?
8.
6 times 8. And 6 times 8 is 48. What will be left over?
That's 6.
8 minus 8.
0.
4 minus 4.
0.
0. So my answer is 8. And if I multiply that by 6, I know 6 times 8 is 48. That should look like that. And you should check your work. See how that works, Felicia?
Mm-hmm.
Is that helpful?
Mm-hmm.
All right,
Okay.
and watch how this works. We take your name, we fold it in half, we fold it into fourths, we put it in the apple. You stay tuned and watch till the end of the show as we are getting ready to take a break. Our break time is your break time for you to check out your homework, see what you have to get help with, and give us a call. Work on the challenges so that you can call back and have a solution ready for us. Watch the PSA, the public service announcements that are coming up, including maybe our mini lesson or email corner, and we'll be back in a few. So come back to us.
Hello, my name is Jeffrey Greer, and I am here with your email corner of the day. Today we are going to work on adding mixed numbers with unlike denominators. Here's our problem. 5 2/3 plus 3 3/9. What we need to do is find a common multiple of both 3 and 9. The common multiples of 3 is 3, 6, 9. The common multiples of 9 is 9. Stop right there. 9 is a common multiple of both 3 and 9. So we can leave 3/9 alone and work with 2/3. Since 3 times 3 equals 9, we need to multiply by 3. 3 times 2, and we get 6. So now we have 6/9. 6/9 plus 3/9 equals 9/9. Now we need to add the whole numbers. 5 plus 3 equals 8. What we have now is 8 9/9. 9/9 can be reduced. This equals 1. 8 plus 1 equals 9. 9 is your answer. Thank you for joining me of your email corner of the day. Thank you.
You can never know which pool safety step will save a life. Until it does. No matter how safe you feel, adding multiple safety steps can mean the difference between a close call and a call to 911. Simple steps save lives. To learn some new ones, visit poolsafely.gov.
When lending a helping hand to those struck by disaster, we often send help in the form of goods. But did you know how much money goes to the shipping and storage costs for just one of these? It could have been used to provide necessities such as clothing and shelter for so many more people in need of our help and love. The love helps. Send helpful love. Cash is best. For more information, visit www.cidi.org.
Welcome back to Count on Us, your homework help channel. You can reach us here at 301-772-0080. Call us up with your homework questions. I know you have some. I'm Mr. G.
I'm Miss Sternberg, and we are helping the students that are calling. We've had a couple of callers who've called in a couple of times because they can get through on those lines. The lines are open for you to call now. We've had several students solve some challenges as well. Our 24 challenge, a lot of our students are getting really good at it. They have contests at school, and the First in Math does a lot of the 24 challenge activities as well, and we have winners from the county that go to a special program at the end of the school term, probably sometime in May, I think it is. So work on those skills, work on them right here with us, as Anthony is doing, because Anthony is on the line. Hi, Anthony.
Hi.
This is Count on Us. Tell us what, you go to Carmody Hills?
Yes.
And what grade are you in?
I need help on 9 times 42.
Okay, what grade are you in, Anthony?
Third.
Third grade. Now, I know a lot of third graders are just starting their multiplication facts. So 9 times 42 sounds like a pretty big problem for a third grader. Do you know your facts, Anthony?
Yes.
All right, great. So let's see what we're going to do. Even though we're writing 42, we're thinking 9 40s and 9 2s. And then we kind of put them together, okay? So how much is 9 times 2? Anthony, how much is
9 times 2?
9 times 2 is? Oh, no. Sounds like we lost Anthony. Anthony?
Are you there?
Are you there? Can you hear?
Yes.
Oh, good, you're back. I guess you were counting 9 times 2. How much is 9 times 2? Did you figure that out while you were away?
Anthony!
All right, so 9 times 2, I think, Anthony, we lost him. His line is having a short circuit going on. But 9 times 2, we still want to solve the problem. 9 times 2 is 18. Again, we have 8 ones and 1 10. So we put the 8 ones underneath the ones place, and we regroup or rename or bring that 1 over to the tens place, and we remember to add it when we multiply our tens. Now, a lot of people, we say 9 times 4, but then that's fine. But remember, you're really talking 9 times 40. We're in the tens place. So 9 times 4, basic fact, is 36, or 360. 36 plus 1 more makes 37. So really 370, and the 8 ones that we had from 9 times 2 is 378.
Ta-da!
So very important that, again, Anthony, as a third grader, I know I just talked to some third grade teachers who were asking for some strategies to help their students learn their facts, how many facts they're expected to know, how quickly they should know them. And by the end of third grade, snapping those fingers like that.
Automatic.
So when we say 2 times 19, it's not 2 times 19 is 1, 2, 3, 4, 5, 6, 7, 8, 9.
It's not gonna make it.
Not gonna make it. 2 times 9 is 18. You know the answer on the snap.
Just like that. Boop.
Okay? And that's just an automatic, we call it fluent with your math facts. And you got to do it, third graders. So every night, study for a couple minutes. Study those math facts, write them down, look at patterns, look at doubles, look at the double numbers, look at the easy ones. When we're looking at patterns for studying our math facts, what I like to give my students, I give them a table.
Oh, no, wait. Before you go on, we have to put Anthony in our apple.
Oh, well, let's do that. Anthony, I hope you're watching.
Anthony! Yeah. You're in the apple.
In the apple.
In the apple. Okay, now you can go ahead.
You know what? Actually, let's take the caller, then I'll go ahead. All right?
Do we have a caller?
We do.
We have someone in the TV world.
Someone is calling. Maybe it's Anthony calling back.
We are here. We are here.
All right, so then let me start off with this chart. And your teachers, a lot of teachers have charts that are already the math tables.
Yes.
So I'm going to just do a quick one to show you something really quick. If we do 0, 1, 2, 3, now I'm going too big, I will never fit it. You should be learning at least up to your tens tables. Some teachers make 11 and 12s.
Yes, I do up to 12.
Up to 12.
Fifth grade, we go up to 12.
All right, so 1, but I'm only going to go up to 10 on here, mostly for space and
10's
time.
good.
3, 4, 5, 6, 7, 8, 9, 10. Coming down, I'm going to do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Kind of making an array, making a table. If I make my lines in here, And I was going to ask Mr. G to make some lines, but he's falling asleep on me over here, so I'm going to make my own lines. And I'm going to go down and make a line in between. And then I'm going to go across. So actually, we could find the area. Ooh, that one got wiggly.
Ooh-wee, that's one of my lines.
It wiggled on me. And typically, you'd use graph paper or a ruler, or as I said, most of your teachers have these already made.
I had
charts.
graph paper I brought too. I forgot
Oh,
about
okay.
But
So we're going to cross these out, and we're going to build our own table. And this will tell you if you know your facts, how many of your facts you know, how many you need to learn, if you build it as you learn your facts. So we have the table set up here, and what we're going to do is show you how to work this table once we take our caller. So why don't you take the call, and
Topanga
is back. We like it. If we can't get new callers, we'll take the old callers back.
What do you have for me, Topanga?
I wanted to know if that 1.5 fraction can go, like, one half fraction can go into 3/4.
Ooh, 1.5 can go
If the half fraction can go into 3/4. So can you divide 3/4 by half is what you're asking? There we are, Topanga, hearing ourselves again. You have to turn that volume down.
We can turn this half into fourths, but it won't be 3 of them.
Are you
Topanga?
asking about equivalent fractions or dividing them?
She's 4th grade, right?
Yeah.
Equivalent.
The equivalent fraction. So what happens is, if we take that 1/2 and cut it up into 4 equal pieces, 2 times 2 equals 4. 1 times 2 is 2. So it'll be 2 out of 4, not 3 out of 4.
But if you take the 3/4, you can make an equivalent fraction by multiplying both of those by 2. What would you get there, Topanga?
You will get
4 times 2?
4 times 2 equals 8,
There you go. And what's 3 times 2?
and 3 times 2 equals 6.
There you go.
So that's an equivalent fraction to 3/4, but 1/2 and 3/4 are not equivalent. As a matter of fact, 3/4, you heard, I'm not sure that you 4th graders are working with simplest form yet, but this is 3/4 because 3 is a prime number. This is the simplest form, the smallest this number can be made into, so we can't really make it into another equivalent fraction going smaller. We can only get bigger, or actually our numbers get bigger, but our fraction pieces get smaller by multiplying. Okay?
Okay, well, I still want to know, what is the difference
Between?
between 1/4 and 3/4?
1/4 and 3/4?
No, I mean 3/4 and 6/8.
3/4 and 6/8. Those are equivalent fractions. It means they equal, they cover the same space. They're just divided into different size pieces. And Mr. G is going to draw you a picture.
Remember my rectangle earlier?
Maybe it was the rectangle that threw her off.
Yes.
It's funny.
Okay, if I have... You don't like my squares here?
Your equal pieces are just so far off from equal.
Oh, yeah, that's way off. Woo-wee! My head's crooked.
There we go. That's better.
That's better. So, if I have 3 out of 4 equal pieces, right? I can cut this same rectangle into 8 equal pieces. Watch this.
Want to use a different color?
Sure.
So as long as he keeps his pieces equal, he can keep cutting it. So he's cutting.
My favorite color.
Favorite color's red.
So
like
now I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. I had 3 out of 4 pieces in the beginning. Now I have 8 pieces, but out of those 8 pieces, the amount that is shaded in are 1, 2, 3, 4, 5, 6. You see that, Topanga?
Yes.
That's why they are the same. They're equivalent. I didn't make this bigger or anything. I cut the same pieces up into smaller pieces. You see that? So I have 4 pieces. Now I have 8. 3 of them were shaded in. Now 6 are shaded in. And those pieces are smaller.
So think of that candy bar. I'd rather have 3 out of 4 than 6
out of 8.
Well, if you gave me 6 out of 8, that's fine. It's the same. But
if
I'd
I only
rather have
got one of the 8 as opposed to one of the 4, then that's a problem.
Right. Does that make sense?
Yes.
All right. So because you asked what's the difference, and these two are equivalent, so there is no difference between them except for their name. Their
and the size of each shape.
But their value is the same.
You got that? It's just like having 2 quarters or 5 dimes.
That's a good example. So their value is the same, but you have different ways of showing that value. Okay?
You got it, Topanga?
Yes.
Does that help?
And you'll learn more as you go on in 4th grade. The key to doing these fractions is that multiplication. I'm going to keep on saying it until you guys all hear it and get it. You have to know your multiplication facts.
Well,
I know
my multiplication. It's just like 4 times 4, like my 4s and my 3s and my 11s and my 10s.
You know them? Those are the ones you know? Or you're working on? Great, that's
4,
great.
3, 11, 10.
She knows her 5s too, and she knows her. She just did her 2s with us.
Yeah, I'm sure she knows too.
But I'm still stuck on my 12.
Well, 12s are tough.
That's okay.
Do you know your 6s? Do you know your 6s, Topanga?
No.
Okay, yeah. I was going to say, so if you learn your 6s, then you just have to double that to get your 12s. So there are some strategies which we were going to talk about, but we got some callers we want to take about how to help you with your multiplication tables. But 12s are hard. You know your 10s are easy and 2s are easy. You can do a 10 and a 2 and put those 2 together. Does that make sense? I just put your name in, but look up here real quick. I know we have another caller on the line, but Topanga, you still with me?
Yes.
If we want to do 12 times 4, right? Well, that one you might not know like that. But what's 10 times 4? That one you should know. 10 times 4 is?
40.
40, that's a quick one. What's 2 times 4?
2 times 4. 4.
Oh, no, 2 4s, not 1 4, 2 4s. 4 plus 4, 2 4s.
8.
There you go.
And now 40 plus 8 is 48. So that's a quick way of doing 12 times 4. You can do the 10s. Everybody knows those 10s. All we're doing is adding a 0 to the number you're multiplying by.
This how my teacher taught us. She taught us a song that goes, she got 4, 8, 12, 16, 20. She got 24, 28, 32, 46. And
I'm with you. Up to 40. You just did the multiples
of 4.
Of 4. You're just saying the multiples of 4. Okay?
And she also taught us our 11s. Like she said, our 11s were very easy.
Yep, 11s are easy because there's a nice pattern to them. We appreciate all this that you're doing to help us and help the other students who are learning their facts and teaching them songs and things. We do have some other callers on the line that we want to get to. So, Topanga, your name went in again. Thank you. We got just a little while till the end of the show, so you keep on watching while we go and help the next caller.
Brad, are you there?
Who?
Is this Brad?
Yes.
Hi, Brad. How are you?
Good.
Where are you calling from?
Cherokee Lane Elementary School.
Cherokee Lane.
Cherokee Lane is in the house.
They always are in the house. Always.
What grade are you in?
First.
First?
Wow,
Did
you're
you
our
say
first grade caller. If you are in first.
Brad's a little guy. Brad, what is your
deep
question?
voice for a little guy.
Auntie?
Huh? What's your question?
Plus.
Plus? You're adding?
You're adding.
All right, here's the numbers.
What are the numbers?
400.
Ooh, those are big numbers.
400? You're in the first grade. 400. Okay.
Plus.
Plus.
370.
Plus 370.
Um.
There's more?
Equals
Oh, okay. Scared me there. You have an answer there? Or that's what you need to figure out?
207.
It equals what, how much?
270.
270?
No, equals 770.
Okay.
So Brad calls to show off his math skills, not to get help with them.
Hey, yeah. Did you already do the problem, Brad?
Huh?
Did you already do it?
No.
So what is your question? I'm not clear.
400 plus 370 equals 770.
Okay.
So he's sharing with us what he knows about these addition
That's
problems.
true. Do you have a question you want to ask?
Do you have a problem that we can help you with? Or you already have all the help you need?
Yes. No.
All right, we're going to, I think,
Brad?
move on.
All right.
All right, we're gonna help Edwin because Brad got all the
Brad
help he
had the
needs. Brad
answer.
has the answer.
He didn't need us.
He didn't need
just
us.
wanted to hear himself on the,
Yeah, well,
on the
that's
television.
okay.
Which is cool.
But Edwin's on the line. Edwin, do you have a problem we can help you with? Edwin, are you there? Yes.
1,000 times 1,000.
All right, hold on, Edwin. First of all, tell us what school you go to. I can hear
And
myself
turn your
talk.
TV
Turn
down.
the volume down.
Turn the TV all the way down and listen
Not
on
off,
the phone.
just down. What school do you go to, Edwin?
I go to Cherokee Lane Elementary School.
Cherokee Lane. And what grade are you in?
4.
Fourth grade. All right, now tell us your problem, Edwin.
1,000 times 1,000.
1,000. All right, 1,000.
Times 1,000.
Times 1,000. All right, well, this looks like a big problem, but because of all those zeros and what we know about our basic facts, this is actually a very simple problem. What we have to do here is just solve the number part and count the zeros. Okay? Or look at the pattern. How much is 1 times 1?
1.
1. And if we did it times 10, we would say, how much is 1 times 10?
10.
10. So we'd add a 0 in there. So if we multiply the ones with 1 0, now we're going to add all these zeros. 1 times 1 is 1. And count these zeros for me, Edwin. 1.
1, 0.
Okay, 2. Count all the zeros. How many are there?
3.
3 up here and 3 down here. How much is 3 plus 3?
3 times 3 equals 9.
No, not times. 3 plus 3. How many zeros are there? Count them all together. 6 zeros. So we have to put the 6 zeros in our problem, in our answer. 1, 2, 3, 4, 5, 6. So that's our answer, but to be able to read it, we need to put our commas in. So every 3 digits or spaces, we're going to put our comma. 1, 2, 3, comma, 1, 2, 3, comma, because we're separating our units. And tell me what this number is.
1 million.
1 million. So 1,000 times 1,000 equals 1 million. And that's less than Mitt Romney made in a year. I'm just saying, you know, we're doing the math. So, Edwin, thank you for calling. We got your name written down for this problem. Did you have a chance to try one of our challenges? Oh, I guess not. So, Edwin, we're going to fold your name up into half. And, oh, he is still there. We're going to fold it into 2, and then we're going to fold it again into fourths.
And slam dunk it into my hungry
That
apple.
was a slam dunk. I can beat you at basketball. I'm just saying that, too. All right. All right.
Okay.
So I'm going to go real quick back before we end the show to this multiplication table so students can work on this, especially my 3rd graders who are starting multiplication facts. You need to know them in 3rd grade. By 4th grade, you should be a master. 5th grade, we don't even want to talk about it. By 5th grade, if you don't know them, your teacher's upset with you.
Arg!
But
Arg!
set up a table like this or ask your teacher if they have a table that you can use and you can highlight what you know. But if you start filling in this based on what you know and some strategies that you can use, you can fill this table in, and once you have it done, excellent. You'll be on your way. Everybody knows the ones, because anything times 1 is?
Itself.
Itself. So we're going to use this 1 column and go right down here and rewrite these numbers. So let me use another color. How about that red one? You like clicking, I can tell.
I like clicking.
So here we have 1 times 1 is 1. 1 times 2 is 2, 3, 4, 5, 6, 7, 8, 9, and 10. Because 1 times any number is that number. then we're going to go across. We're going to go one row across and do the same thing. 1 times 1 we already did. 2, 3, 4, 5, 6, 7, 8, 9, and 10. The 2s, everybody knows 2s. Skip counting is, well, you skip count by 2s all the time. It's our doubles. It's the number plus itself. Those are the ones we have memorized simply when we do it in first grade with our 2s of skip counting. So 1 times 2 is 2. We already have that filled in. See, sometimes we already have ones filled in the row or column. 2 times 2 is 4. 4. 2 times 3?
6.
2 times 4?
8.
5?
10.
6?
12.
7?
14.
8.
16. 18. 20.
He doesn't need me to say the numbers because he has that pattern. 2, 4, 6, 8, 10, 12. We're going to take that same pattern and go across. 2, 4, 6, 8, 10, 12, 14, 16, 18, the wiggly one, 20. All right? Multiples, multiples. We're multiplying and getting our multiples. Now, sometimes the 3s people don't like. They don't like the 3s. They're harder. I don't either, but we can skip that for the moment. Let's skip to the next easiest one. The 5s.
I think the 5s.
We love the 5s. Those are our nickels.
5, 10, 15,
exactly.
20, 25, 30.
All right, go ahead. So I heard the 15, 20. What was next?
25, 30.
25, 30.
35, 40.
35, 40.
45, 50.
45 and 50. We do a row, we do a column. So here's the columm. Let's go across the row. 5, 10, 15, 20.
25, 30.
Oops. 25 was already there. 30.
35.
35, 40. 45, 50. Look how much already we have filled in.
Right.
With no struggling at all. The 10s are easy. 10, 20, 30.
Easy, breezy.
Those are our dimes.
Oh, my
30,
goodness.
40. We have 50, 60, 70, 80, 90, 100. Coming across. 30, 40. Got 50, 60, 70, 80, 90, 100.
So what's happening here is if you know 3 times 5, you also know 5 times 3.
Exactly. We know the reciprocal or the commutative property. So
It means it travels. They go from one side to the other. It doesn't matter. They're still the same.
And this chart becomes a mirror image. Whatever we do on one side, we're doing on the other. So let's quickly go. The 9s are easy because the pattern is there. We know we have a 9, 8, we have a 7, and the one goes up, and the 1's column goes down as the 2 column goes up. So we have a 1 and an 8, a 2 and a 7, a 3 and a 6 for 36. There's our 4 and our 5. Then they start rotating again. Our 5 becomes 4 and a 5. So 54, 63, 7 and a 2, 8 and a 1. Let's go across. 2 and a 7, 3 and a 6, 4 and a 5 is there. 5 and a 4. 6 and a 3, 7, 2. We have the 8, 1. We have the 9, 0. And we only have a few more blanks, and you do know the 3s and the 4s. The 6s are really, 6s and 7s are the only ones you have to look at. And most of those get filled in.
Right.
But we're running out of time, and we're going to end it with you guys thinking about the ones you know, the ones you don't know, and how you can help yourself to learn the rest of these facts. Because next time we come back, you got to know your facts.
You have to practice.
All right, let's do our quick.
You have to practice.
Pull a name out. Because our show's about to end. Remember, someone's coming through. Remember that the next version of Count on Us, the middle school edition's coming on from 5 to 6 o'clock. Who did we have?
Tamawa!
No surprise there. No surprise. His name was in the most. We hope that you learned something and some strategies with fractions and with our chart. For Mr. G and myself, please remember that you can always
count on us.
Welcome to the Count on Us mini lesson of the day. I'm Miss Shirey. I'm going to talk to you today about place value. Let's look at our problem. Place value, a mini lesson on the value of numbers. Our objective for today is students will use place value blocks and a place value chart in order to understand the value of numbers. Here we have a problem. It says Ian and Olivia were trying to decide who had more baseball cards. Ian has 4,237 cards. Olivia has 4,327 cards. Their friend Sammy said that they each had the same since all the digits were the same. Was Sammy right? Let's take a look at a place value chart to help solve the problem. Sometimes a chart like this can help. Ones, tens, hundreds, thousands. If you put the digits in each of the place value places, we can tell who has the larger number. Here's Ian's number, 4,237. Here's Olivia's number, 4,327. Look in the highest place, then keep going. You can see they both have a 4 in the thousands place, but look, Ian only has 2 hundreds, Olivia has 3. Let's look at it with a place value blocks. Here's a picture that shows you 4 thousands, 4 thousands. They're the same, but you can see Ian only has 2 hundreds, where Olivia has 3 hundreds. You can see by the place value blocks that Olivia has more blocks than Ian. Each place really does have a certain value. Sammy wasn't right on this problem. Well, thanks for watching. We'll see you next time on our Count on Us mini lesson of the day.
Hello? Hello? I've been on the street for a while. I saw your poster outside. I don't know what to do.
National Runaway Switchboard, how can I help? Call 1-800-RUNAWAY to make the connection.
You have the time to give. You have the capacity to care. You have the experience to contribute. And your country needs you, one of its greatest assets. Americans whose lifetime of knowledge and know-how will make the difference. Take what you learned in the workplace and apply those skills to your community. Shape tomorrow by being a mentor and tutor for children. Make independence a reality for people who need assistance and companionship to continue to make their house their home. Make a difference today. Get involved.
What's happening? It's your Royal Hypeness, Angie Angel, your Mike 93.9 WKYS is my radio station, 6 to 10 p.m. Check me out. And when I'm having problems with my math, I'd call in to Count on Us. I can always count on them.
Because how many ways are there to solve math?
Many! Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel?
All right, so let's add 3 here and see what happens.
First, measure first. I need you to double check yourself. So the second equation for solving perimeter is
2 times